I want to share with you another one concept before going to the functions. Okay, so most of the times we are observing, and we have seen many times equations like this. Like you see, 2x plus 9y equal to 20. Are you familiar with this type of equations?
Yes,
Yes, sir.
Okay, good. So you see here, actually the x and the y, okay, the x and the y are unknown. Okay, so we don't know at this moment what are the value of x and what is the value of y that collectively become equal to 20. You know, the equation has one equal sign, this equal sign, and there are two parts of this, one to the left of the equal sign and one to the right of the equal sign. So whenever there is equal, okay, this equal means that the left hand side is 100% equal to the right hand side. And you remember in C++ this equality was having different meaning, right? This was assignment operator. Don't confuse with this. Now we are in mathematics, we are not in programming language. So this equal actually means the programming, this one equal, okay, meaning to say really equal. So you can say that the left hand side is 100% equal to the right hand side. So the left hand side will must be equal to 20, then it become equal to the right hand side. Okay, so to make the left hand side equal to 20, there are many possibilities. Okay, many possibilities, meaning to say that actually the x and the y may have many different values, meaning to say we can fix different values of x and different values of y to get the collective answer as 20. For example, how? Okay, and these equations are called linear equation of two variable. Two variable, you see, the x and the y are the variables. Why it is called variable? Because its value can be changed, and at different values of x and different values of y, we can get the answer 20. How? Like this. You see, if I put the value x equal to 10, okay, and y equal to 0, then what will happen? You see, it will become like this. So we can write this like ordered pair in a bracket, x and y, like the variables we put in a bracket, and then we can test for different values of x and y to get the answer 20. Okay, so if we put like this, x equal to 10 and y equal to 0, then actually we can get the answer 20. You see, 10, x equal to 10, so 2 times 10. Note the point, in mathematics, if there is nothing mentioned, no plus minus is mentioned between a variable and a number or constant. Mostly it is constant. Like for example, this one, you see 2x, okay, 2x. So it means, you see, here in the middle there is no minus, no plus, no division, nothing has been written. So if nothing has been written, it means it is what? You understand already? It means it is multiplication. Okay, yeah, very good, very good. So it will be multiplication. So here in this case, the 2x means 2 multiplied with x. Okay, so if x equal to 10, then 2 10 equal to 20. So here this will become equal to 20. And the other one, if y equal to 0, and we know that everything multiplied by 0 equal to 0, so this whole component will become 0. So this will become 10, this will be this will become 20 because 2 times 10. Okay, 2 times 10, and this will become 0. So as a result, this will, the whole left hand side will become 20, and the right hand side is already 20. So the left hand side is equal to the right hand side. Then we can say that 2x plus 9 equal to 20 only if x equal to 10 and y equal to 0. Hi everyone, until this point, is it okay, clear?
Yes, sir.
Yes,
Oh,
sir.
Yes,
yes.
sir.
Oh, very good. So it means mathematics is easy. Uh-huh. You don't believe me.
No, sir.
Okay, don't worry, mathematics is actually easy. Yeah, we will try. We will try. I will try my best to make it easier for you. But I don't think so that you are believing me. Maybe because if you are believing from very long time that mathematics is difficult, I don't think so that I can easily replace that belief by another one. But I will try. Okay. So let's see. So in this case, if x equal to 10 and y equal to 0, then the left hand side is equal to the right hand side. Do you think that there are any other possibilities also? Any other possibilities if we give another value, some other value to yes, okay, good, some other value to x and other value to 9, then we can get this one, the same answer again. And you see, this is why the x and y are called variable. Meaning to say, you see, by x and 0 also we can get the same answer, and actually we can change by some other values also the same answer. There are many possibilities. Okay, for example, like this, you see, if I replace, just example, there will be other possibilities also, but in case of this, if I replace x by 3, and 14, no, sorry, y by 14 over 9, okay, then actually we can again get the same answer. How? Let me, like this, you see, if x equal to 3, then it will become 2 times 3. Okay, and the other one, the 9 times y will become 9 times 14 over y. And you know that if we, when we write like this, you see, it will, this part will be actually like this, you see, 9 times 14 over 9. Oh, the 9 is red. Let me change this one to, this will be 9. Is it okay? So if 9 is above the division line also and below the division line also, then you can simply cross this 9. Or in other words, 9 divided by 9 is equal to 1, right? Is okay?
Okay, sir.
Yes.
So the output of this component is actually 14. Okay, so the component of the output of this component is 14, and the output of this component is 6, because 2 times 3 equal to 6, right? So 6 plus 14 is equal to 20. And now the equation is again correct. So you see, we can change the value of x and y in such a way, in such a style, with such values, that the combined output is equal to 20. Then the whole equation is correct. Okay, and therefore you see, the x and y can have many different possible values, therefore they are called variables. Okay, so I hope it is not a a complicated concept anymore. So meaning to say, it doesn't mean that you have studied this type of thing before or not. So you see, I think it is quite easy. Every one of us can understand now. If all those students who didn't study maths before, you just think now that okay, now I am studying mathematics and now I am learning it, it's not difficult. So if any one of you are facing problem, I don't understand, as I told you before, you can stop me again and again, and I will explain again and again in such a way that should not be a problem for you. I hope I just hope that I will be able to explain. Maybe sometime I cannot explain. Okay, so until this point, hopefully should not be a problem. So yeah, this is the solution. Okay, now if it is like this, then okay, sometime we have an equation like this. Okay, equation like this, and that equation have one final output. Okay, so the final output, the final answer, sometime we need to show on a number line. Okay, this is actually called number line or plane. Okay, no problem. So for example, if let's suppose our output is 4, just for example, so in case of the 4, if there is any equation like that whose output is 4, then where will be that number 4 at this number line? So you see, it will be, you know, this 4 is positive and this number line has two components, 0 and negative side and positive side. And note the point, 0 is positive or negative? Can you tell me? Anyone? Neutral. Yeah, so yes, very good. 0 is not positive and not negative. Don't make this mistake in a future. Wherever there is 0, 0 is not positive, not negative. Okay, I think Alex, your internet is slow or problem. You are getting in and out of the meeting. Okay, yes, good. So 0 is not negative, not positive. Okay, now if our output is positive, then we will look that number or the place for that number on the right hand side of the 0. So you see, then after 0 is 1, then 2, then 3, then 4. So it means if we have the output 4, then in this number line the 4 will be here. Okay, will be here. And if let's suppose this number is negative 4, then we will go on the left hand side of the 0 and we'll find on the number line here. So this is the way to represent the plus 4 or minus 4 in another way, in another style, in a number line. Okay, so hopefully this will also not be an issue. Okay, like for example, this case 2x minus y. You see, number line is used when there is one variable in the equation. Note this point. Okay, when there is one variable, not like the previous case. Here were two variables. If two variables, then we cannot use one number line. I will explain to you this one in the coming slide. But now let's switch to such a equation which has only one variable, like x. 2x minus 3 equal to 7. So now in this case we can put any value for the x. 2x minus 3 equal to 7, any such value for the x which result into 7. For example, if I put x equal to 5, so 5 times 2 will be 10 and minus 3 result will be equal to 7. So it means that 10 is equal to 5. Okay, so where to find the value of x? The value of x on the number line, where it will be? Can you help me? where x will be located at this number line?
5.
Yes, very good, very good. So x value will be here. Okay, so in this way, note the point. If we have an equation having one variable, then we will use a number line to find or show the value of that variable on the line. Okay, why we are studying this? Actually, slowly I am bringing you towards the graph, because later on we will design a graph, we will find the value of graph. Okay, so at that time we will know, it will be easy for us when we learn this thing. Okay, so the conclusion is that in this case we will learn like this. You see, solution is that the x value it become 5 and 5 will be here. In case of two variables in a equation like the previous one, we have a plane. Okay, not one number line. You see here was one number line. One number line means that a straight line from left to right. Okay, a straight line from left to right. This is one, this is called number line. But when if it is like this, then it become plane. Some people call this Cartesian plane because it was first introduced by a scientist, Cartesian. So this is why it's some people still call that a Cartesian plane. So this plane we are representing in the form of x and y. You see, x and y. So the x value are from left to right. Okay, the x values are from left to right. I should change maybe like this. Okay, you see, left to right, and the y value is I'm so sorry, my mouse has some problem. Actually, I think the setting has been changed. Sometime one single click is equal to double click. Okay, so I will try my best to control. Okay, and the y value is from top to bottom. You can simply think like if you have let's suppose your mobile screen. Okay, your mobile screen. So in your mobile screen, from left to right, okay, left to right, or you can say the width of the screen, VID. Okay, sometimes the, the writing is not easy. Okay, the width is x value. Okay, and the height or the length are from top to bottom of your screen. You can say the height of the screen or length of the screen, but I think the height will be a more suitable word. So the height of the screen is the y value. Okay, so when there are two values, two variables involved, one x and one y, then we use a plane. Okay, and actually this plane play a very important role to understand a two-dimensional word. You see, actually the x and y plane show the two dimension. We can also call this x dimension or x axis, and y dimension or y axis. Okay, and the middle point of these two will be the center point of these two axes. And if you look at around the everything around you, or the universe, you can actually easily find this concept everywhere. Like for example, the room that you are sitting there, it has a width also and it has a length also, right? Don't consider the height yet. Okay, then it become three-dimensional. So if we just focus on two dimension, okay, then every 2D object has length, width and length, like your mobile screen, width and length. So conclusion is that if there are two variables in a equation, then we can represent that equation in a plane. Okay, in a plane or in a Cartesian plane. Okay. Okay, sometime. Yeah. Okay. So I was explaining like the x component and y component. So the x from the center, if you go to the right, x will increase. From the center, if you go to the left, x will decrease. And from the center, if you go up, y will increase. And if you go down, y will decrease. So it means when we go to the more left, then the x value will become negative, and you see more negative value means more smaller. For example, negative 10 is less than negative 2. Are you agree with me? Negative 10 is less than negative 2.
Yes, sir.
Okay. Can anyone give me some example from real life to which the example should explain that yes, really negative 10 is less than negative 2. Any example, any one of you? You see, this is the sharing point now that we will learn together. If anyone have a good idea to explain, please go ahead.
Can I try, sir?
Yeah, try please.
It's because negative 2 is much closer with 0 than negative 10. So negative 2, it's much closer with that positive number, than negative 10 itself. I don't know how
Yes,
to explain it.
very good. Yes, really, this is one possible explanation, that the more closer to positive area will be bigger than the far one. Yes, this is one possible solution. Anyone else? Anyone else from different perspective, different point of view, different style? Anyone who want to try? So you also think the same? Okay. But you should think differently. Don't simply follow someone else. Huh? Okay, let me give you different point of view. For example, if let's suppose negative means lose. Okay, lose. Negative means lose. Let's suppose you are playing a game and you lost. Yeah, the hot and cold is also possible. Maybe we will come to that one later. Now I have already started another perspective. Let me complete. Okay, so let's see. Negative means lose. Okay, and positive means win. Okay, so if you are playing a game, so if you lose 10 times is better, or if you lose 2 times. Of course, both are bad, but which one is more bad? Huh?
The 2 times.
Yeah, 10 time is more bad. It means yeah, that we did many mistakes. That one is more bad situation as compared to 2. Okay, another perspective from the same loss and win point of view. Okay, let's suppose you lost 10 ringgit. Okay, it is a good way, better, or if you lost 2 ringgit. So of course you will be very sad if you lost 10 ringgit as compared to 2 ringgit, right?
Yes, sir.
Okay. So meaning to say, the more negative is the more worse. Okay. The more worse, and the more yeah. So let's bring to the point that the bigger negative number is basically smaller, lesser than a smaller negative number. Okay, so This anymore. I can't repeat again. Okay, so we were talking about quads. So the plane has 4 quads. Quad 1, x, y both positive. Quad 2, x negative, y positive. Quad 3, both negative. Quad 4, x positive, y negative. Okay, so the 2D plane has 4 quadrants, 4 quads. The first quad is positive. Second, x is positive, y negative. Sorry, x negative, y positive. In the third one, x is also negative, y also negative. In the fourth one, x positive, y negative. Okay, so let's go ahead and let's try to find different values, added pairs in a quad. So if you see, let's suppose the first one, if we have an added pair like 5 and negative 5. So you see the first value represent x, right? Okay, x. So then we see that the x is positive. So if it is like this, then we will start from the center point and we will go to the right, to the right, to the right, that until we find here. Talking is also not easy. Okay, so if the x is positive, we will go from the center point the center of the plane to the right, because on the right is the positive axis. Then 1, 2, 3, 4, and we will find the 5 here. Okay, the other lines I don't know maybe why I have done. Maybe there is another example later on, but forget about this one. I am thinking about this. So the 5 will be here. Now yeah, if it is, I think I should, yeah, I should bring this one. Maybe I have done for this one. For next one, next example, let's go ahead. And for negative 5, so we will go down. So 1, 2, 3, 4, and 5. So it will be here, this one. So if you join this positive 5 with the negative 5, so it will be here, and it can show like this point. Okay, this point. Okay, so in this way we can say that we can find on the basis of this drawing that this ordered pair fall in the 4th quad of the plane. Okay, similarly the next one, let's suppose we have 7. Oh, I have drawn for this one. So, no, not for this one also. I think the one of my arrow is wrong, so you just ignore it. Okay, so 7 and 3. Can anyone help me? This one, oh, someone was asking this one. Confuse her for a moment when I mute myself, or what?
It is the pouch.
Huh? Any question? Is there any question? Confusion?
No, sir. It is the pouch.
Oh, okay. Okay, so the next one, the positive 3 and negative 7, this other pair can fall where? Anyone? Try.
Can I have a try?
Yeah, please go ahead.
It is on the right X,
Yeah, okay, right, x. So x is positive. Okay.
and then go to the below Y,
Okay.
which is negative 7.
Yeah, okay, very good. So you see 7 is negative, so I will go down until this point. So this, if I just draw, then it will be like this. So this other pair again fall in the 4th quadrant. Okay, and next one, who want to try? Who want to try? Or just tell me the quad number, in which quad it will be?
Quad 3.
Yes,
Sorry.
yes, good. Quad 3, because x is also negative, y is also negative, so this will fall here. Okay, in this quad. Okay, yes, you are right. Okay, the other one, 4 4
Second.
4 4, not second, because second one is this one. You see, second is this one, and here
Oh,
x
different.
is, yeah, x is negative. No problem. This is that mistake. Like when you are trying a game, or yeah, so mistakes makes ready for the future. Okay, so 4 4, x is also positive, y is also positive, so it falls here. Okay, no problem. Next one, 0 0. It falls where?
It's fall on this in the center, right?
In the center. So which quad it will be?
Can it be a neutral one?
Yeah, very good. It doesn't fall in any quad because it's exactly in the center, and the center is not positive, not negative. Both values are 0, so it doesn't have any quad. So remember, if there is any question, maybe in an exam or quizzes, that any one value, for example, if I give you a value like this, that 0 and let's suppose 10. Okay, you see, just to confuse you, 0 and 10, so it is in which quad?
The first
Two
one,
at center.
right?
One says right, one says center. Okay, try. Anyone else try? My question is about quad. It falls in which quad? Try, unmute yourself, please.
1 or 4.
One, okay, let's try on one. So you see, if I say it is one, so you see, it means one means somewhere in this area, right? So it means that I will must come out from the center. Maybe the x must be 1.1 or 1 or 3 or whatever, but it must have some value to come out from the center. Okay, and the y already have a positive value, so okay, it is here. You see, positive is here, the x is here. So if I join both of them, okay, if I join both of them, where is it? Huh?
Middle of it.
Yeah, so it means it is not in any quad, it is over the y-axis, right? It is not actually in any quad, it is just on the axis. Okay, so so try to don't make this mistake. The same go for opposite of this. For example, if I tell you that, oh, yeah, if I ask you that, let's suppose 5, okay, 5 comma 0 falls in which quad? I hope this time you understand, right?
Yes, sir.
Yeah, so this will fall on which axis?
X.
On x-axis or y-axis?
X axis.
Yeah,
X-axis.
x-axis. Very good. Because you see, the x will, if I go here, the x, oh, sorry. No, I think I remove it. Sorry, so this is 5 and 0. Okay, so 5, if I go start from the center, 1 2 3 4 and 5, so 5 is here, but the y is where? Y is 0, y is just here. So if I join these two, so then it will be here. So it doesn't fall on any quad, it fall over the x axis. Okay, so it's like the room that you are sitting in, it is just on the one wall, inside the wall, it is not even inside the room. Okay, so it fall on the x-axis. So note this point, that whenever any value of x or y is 0, then at that time it doesn't fall on any quad. I hope you understand it. Yeah, you see this one mistakenly I put the 5 at the place of 7. So no problem. You see, I put this -5. No, positive 5. It is not 5. You see, it is 7. Yeah. Okay. It will be like what? Like positive 7. 7 comma 5. Yeah. Then 7 plus comma -5. 7 comma -5. Then this drawing is correct. Okay, no problem. You see, I am also making mistake. So nobody, the human is error. So everybody can mistake. All the products, the navigation system, everything is based on mathematics. And all the advanced technologies, uh, intelligent devices cannot perform a single function without mathematics. The same concept you can apply on self-driving car. Okay, nowadays the future, in the future you will see a self-driving car. Now you see from these values point of view, you think that how the self-driving car will move, how it will find the direction, the distance, the speed and the obstacle, all those stuff. So my point is that actually mathematics is the mother of all subjects and all knowledge. Any knowledge, when it can be represented in the form of mathematics, then is useful. If anything you cannot represent in the form of maths, then it is not useful. For example, if any one of you say that I can make a nice coffee, you claim that you can make a nice coffee, but you don't know how much water, how much sugar, how much coffee mixed together, how much temperature should be there, and how to mix all these things to find a coffee. Do you think someone will believe you that you can make a coffee? Hmm? Hello. Maybe. Oh my gosh. If okay, let me ask you. Let's suppose if you claim that you can make a very nice coffee, and after that, when you claim that, and after that, I ask you that, okay, can you please tell me how much sugar you will add, how much coffee you will add, how much water you will add to make 1 cup nice coffee, and at that time you don't know how to do. So then, do you think you are the best coffee maker? You see, if you just mix up everything, your coffee, if accidentally become okay, then will be okay. Otherwise, no. What's your experience? Hmm? Then accidentally puts. Oh my God! Yeah, you see. So you see, if you don't put all the amounts, if you don't put all the amounts in a proper ratio and a proper amount, you see, the ratio and the amount is actually mathematical terms. Okay, then this cannot result in a good product. Okay, so in the same way, the Google map works on these mathematical values, subtraction, addition. Okay, and all the subtraction addition can find the distance, it can find the direction, and on the basis of this, it guide you where to go. And then we think that it is so intelligent because it tell you even few hundred meter before any turn. That, let's suppose on the next roundabout you will have to go on the third exit. Okay, so actually all these things are based on mathematical calculations. The system calculate from your place to the roundabout place and find out the distance. So if the distance is, let's up within the range of the message, meaning to say if it is, I think near 500 meter, mostly the system gives us a reminder that at this point you should turn left or right or which exit. So you see, actually all these values are based on mathematics. My only point, I am just trying to say that mathematics play a very important role in our daily life. Yeah, so a relation is any okay, now you see the equation that like x plus y equal to 3. This is also called a relation. Okay, a relation. So a relation is any set of ordered pair. So in this case, x plus y equal to 3. So you can put 0 and 3, you can put 1 and 2, you can put 2 and 1, and so on and so on and so on. Is okay? There are many possible values to satisfy this relation. Okay? Okay, good. So this type of ordered pair set is called a relation. Okay, so like for example, we can represent like this. This is just a general example, that let's suppose a equal to, the a is a relation and it is composed of ordered pairs like 3 comma 5, 9 comma 6, 1 comma 3, 8 comma 7. So this is one relation. This is called a relation. Another one possible relation, that if let's suppose we represent people and their cats, like for example, sorry, their pet, like John have a pet cat and Matty has a pet as a dog and James has a pet as a bird, and so on. In the same way, we can represent like the students in the form of ordered pair as a relation, like student name and metric number. Okay, let's suppose if I just represent, let's suppose student A and metric number is 1 2 3 4 and 5. Okay, 5. So this is one ordered pair. Next ordered pair will be student B and its next metric number. Next ordered pair student C and another metric number. So we can represent any type of data in a relation like this. Okay, so in this way we can represent. And actually other things, like for example, you see this one, let's suppose city purchases gas from a local station for $5 per gallon, which include all the taxes and fee. So it will be what, like for example, you see the x represent the amount of gas. If we try to represent this sentence in the form of relation like this. So from these English words, if we want to make a mathematical relation like this, then let's represent the number of gallons by x. Okay, and the y will be the total amount, that how much city pays. Okay, then the y is actually dependent on the x, because the number of gallon you purchase, that the same amount you will have to pay. So let's suppose, you see, let's suppose 1 gallon is 5 ringgit. So if you are buying 1 gallon, then the total amount will be dependent on this. So 1 times 5, so y is equal to 5. But if you change the x to 2, okay, let me represent this one like this, that the y is equal to the x time 5, because 1 gallon is 5. So if the x is 1 times 5, then the y will be 5. if the x become 2 gallon, then 5 times 2, the y will be 10. If the x become 3, then 5 times 3, 15, the y will become 15. So you see, if you look at the behavior, the y is totally depend on the value of x. This is why the x is called independent variable. This x value doesn't depend on anything, but the y value is totally dependent on the x value. You see, if it is 1, then the y value is different. If it is 2, then the y value increases according to the value of x. So we can say that in a relation or in the ordered pair, the two values, the one is independent variable and the second one, the y, is dependent variable. Is it okay? The x may be 0, or if the city buy some gas, meaning to say if city don't buy any gas, then the x will become 0. But if city buy some gas, then it may be 1 gallon, 1.1 gallon, 1.2, 1.3, or maybe 2 gallons or 3 gallons. So you see, it may be 0, or more than 0. So this is why sometime, okay, is it possible that city buy negative gallon of gas? Is it possible? Hello?
No.
Yeah, no. So you see, we can understand from the situation that in this situation, the x value should be what? It must be 0, meaning to say city don't buy anything. So 0. Or positive value. So in such a case, we put conditions, okay, on the x value, which is independent variable. So if let's suppose y equal to 5x, but in what situation? The x must be greater than or equal to 0. Meaning to say, city can either don't buy any gas, or if buy any amount of gas, then will be positive value. It is not possible to the x get any negative value. No. So this is, if there is a situation like this, then we provide sometime along with the relation the condition also. Okay, I hope you understand. Okay, so we can say that x cannot be negative. Okay, sometime we represent this one is like this, that the x must be greater than or equal to 0, or must be less than equal to 5 if there is a such a condition. Okay, depends on the situation. Read carefully the text. Okay, so sometime this type of condition we represent in mathematical language. Okay, note the point. In mathematical language we represent like this, that x, you see, we will read this one like this: x such that the bar, this bar means such that is read as x such that x is greater than equal to 1. X such that x is greater than equal to 1. So this whole detail tells us that sometime there will be some condition applied on the independent, on the independent x value. Then that condition will be represented in this way. So sometime it is represented like this, and sometime it is represented like this. Is okay, right? No confusion. Okay, if no confusion, then we can say like this. You see, if we have, okay, another concept is like this, that if we have an ordered pair relation like this. Okay, you see, this is a relation, but inside this relation there are ordered pairs. Okay, 1 comma 2, 2 comma 4, 3 comma 6, and so on. So these are ordered pair. In each ordered pair, the first value which represent the x. If we pick up all the first values like 1 here, 2 here, 3 here, 4 and 5, if we combine all the first values or all the x values, this is also called input values actually. Okay, all the first value or the x value or the input value, that is called domain of the relation. That is called domain. And the second value in the pair, if we put all of them in another list, and then it is called the range of the list. So basically the ordered pair, the first value is called domain, the second value is called range. Or in other words, you can say like input and output. But you see, the input and output is a very general thing. In mathematical terms, these are domain and range. Okay, so these, as I told you, the domain are called input values also, independent variables also, and the range is called dependent variable. It always depend on the input. Okay, like for example, the 1 cup of coffee always depend on how much coffee you input, how much sugar you input, how much water you input. So the final product depends on the input, and the final product that are called dependent variables are range, and the inputs, the first number in the pair is called domain. Okay, now if you see, let me please share with me until now, that until now you are clear. You see, we covered relations, single variable relations, double value relations, and we represented the relations in terms of order pair, and we defined that this order pair is, any order pair like this is called a relation, and the relation is basically composed of domain, the first part, and a range, the second part. So until this point, any confusion? If this is clear, that what is relation, what is domain, what is range. Now I am going to introduce a new concept which is called function. So it is exactly follow the same properties, but there is a little bit difference. You see the relation. Okay, look at the definition first. That a function f, mostly we represent by f in mathematics, is a relation that assign a single value in the range to each value in the domain. You see, you read carefully the definition. Is a relation that assigns a single value in the range. You see, this one to this one, this one to this one, a single value in the range to each value in the domain. You see, every value has a single value in the range and domain. Okay, maybe it is still not clear yet. Let's see. This relation is a function because each element of the domain, you see the domain, is paired with exactly one element in the range. 1 is paired with 2, 2 is paired with 4, 3 is paired with 6, 4 is paired with 8, 5 is paired with 10. Okay, so each domain value has a unique value in the range. Okay, if such a relation which fulfill this criteria, then we call that, we give a special name to that relation and call it as a function. Okay, so let me further explain like this, that you see, in a function, every value of the domain, let's suppose the blue circle is a domain, the other circle is a range, so each value is matched with a unique value in the range. 0 with 0, 1 with 5, 2 with 10, 3 with 15. So you see, there is a unique value. Everyone has a unique output. It is like this, that if you input 0, you will get 0. If there is such a system that when you input 1, you will get 5. If you input 2, you will get 10. If you input 3, you will get 15. Okay, so it represents a function. Okay, so we can define like this also, that a function is a set of ordered pair in which no first component is repeated. Not the point. You see, the focus is on domain. No first component like 0, 1, 2, 3, 4, 5. It is not like this: 0, 1, 1, 2, 3, 3. Like the 1 is not repeated again, the 2 is not repeated, the 3 is not repeated. Not single first component is repeated. So if the relation is like this, that the domain is not repeated, then it is called a function. And for each x, there is only one value of y. Only one value of y. Like this, you see, 2, 6, 9, 1, 2, 3, 2, 13, and 8, 7. What do you think about this? According to the definition, is it function? Anyone? Try. Look at the first values, the domain, and then look at this definition. Is it function?
No, sir. Because it's repeated, the 2.
Yeah, I can't hear you properly. I don't know why. Yeah, but one answer I got, that no, it's not. Yes, you are right. You see, the two is repeated. You see, 2 is here also and 2 is here also. So you see, it is not possible that I put two, let's suppose, 2 spoon of sugar. 2 spoon of sugar give me one time 6 cups of coffee, and one time the same 2 spoons of sugar give me 13 cup of coffee. Is it possible? So you see, it applies on real life. The function is such a relation in which the domain is not repeated, and if there is such a thing, then actually we can apply in a real life. Okay, so in this way, we can apply, and we can think and imagine many real world examples like this. Okay, what about this one? Any idea? Is it a function or not?
No.
Very good. No, because the 2 is mapped with 6 also, and the 2 is mapped with 13 also. It is not possible. Very good. Okay, what about this one? Any idea? Is confusing? So you are not sure, right? Why, Frederick? Okay, look at the definition first. Read the definition. A function is a set of ordered pairs in which
It is functioning because it's not at the first component.
yeah, very good, very good. The first component is not repeated. Don't think about the second component. The second component may be same, but you see, the definition on the same slide, the function is a set of ordered pair in which no first component is repeated. So in the blue circle, there is no repeated number, negative 2, 6, 3, 9. Just look at the domain only. So you see, these type of questions will be there. So you should be very, very clear. Angelina, so now you, I think now you understand. What about this one? This one is also confusing. Okay, Bruce, why it is not a function? Can you tell us why it is not a function? It's repeated, yes. Yeah, sometimes you mute yourself, all of you. Okay, so it is repeated. You see the domain, the first odd, even, odd, even, odd. So the word odd, the word even is repeated several times. You are right. Okay, good. Okay, what about this one?
Yes.
This is a function, right? No. Okay, what about this one?
Function.
This is also a function. Very good. What about this one?
No.
Yeah, very good. This is not a function. That sometimes q is equal to y and sometimes q equal to z. No, it is not a function. So it means like q is repeated 2 times. Okay, so it is not a function. So now let's again define a function. A function is a relation in which each possible input value lead to exactly one output value. In the two example in the left and the center, if you see, every input value has a unique output. It is, and but in the right one you see q doesn't have a unique output. Sometimes the same q is equal to y and sometimes the same q is equal to z. So it is not unique. It is possible that two input produce same output. Okay, it is possible that two input produce same output, but it is not possible that one input, okay, one input produce two different output. Can anyone give any example from real life?
Okay.
Yeah, please try, go ahead.
For example, one person cannot go to two places in at the same time.
Exactly, very good, very good. Yes, very good example. Like you, let's suppose you are using aeroplane, let's suppose. Okay, so it is not possible that from one flight you reach to two different destination at the same time. Very good example. Yes, exactly. Okay, so again, to just repeat that the input values make up the domain and the output values make a range. So if any one of you is confused, not clear, let me know. Otherwise, I think it is quite okay. Okay, now another step is that how to, given a relationship between two quantities, determine whether the relationship is a function or not. If, for example, if there, some relation is given to you, then how you will know that it is a function or it is not a function? So you see, the procedure is like this. They identify the input values first and then identify the output values. Okay, if each input leads to only one, you see, only one output values, then classify the relation as a function, then decide. Even if the whole world say no, it is not a function, you should be that much confident that no, it is a function, because each input produce a unique output. Okay, so this is, you should be that much clear. What about this one quickly? Can or cannot? Function is or not function?
Function.
Function.
Yes, very good. Each input have a unique output. Maybe the output is same, but the input are different. It is possible that jelly donut has the same price with chocolate donut, but in real life it works. It is possible like this. But it is not possible that, you see, if let's suppose one shop one time sell the jelly donut, or maybe at the same time saying to one customer buy 1.99, and at the same time to another customer buy 5 ringgit. Is it possible? Cannot, right? Okay, what about this one? Is a function or no? Is
Function.
yeah, is a function. Yes, good. It's actually the same thing, but just represented in different style. Okay, this one, like student grades. What do you think?
It is a function.
Yes, good. Okay, so these like examples will be given to you and you will have to find out, but you should be very, very clear, very clear. So you see here, in this case, the input is actually not one value. The input is a range, okay? A range of value, like from 0 to 56 is one range as an input. But the point is that you see the same range is not repeated. There are other range, but the same range is not repeated. Okay, so this is also a function. Okay, so how to represent a function mathematically? The notation to represent a function is like this, like y equal to f of x, any function of x. So actually the f represent a function, the x is input value to the function, which will produce the y as a output. Okay, so this is read as y is a function of x. Okay, y is a function of x. The letter x represent the input value or independent variable, and the letter y represent the output. Okay, so okay, next one example, you see a function which represent days in a month. If the m represent month, okay, then such a function which give us the number of days. So if let's suppose the m is January, then d will be what? Can you make an order pair of this? Yes, no. Yeah, okay. Bruce already, it will be 31. Okay, good. Yeah, so it will, if m represent January, then d will be equal to 31. If m represent February, then it will be 28. 28. If it is not leap year, you know what is leap year? Any year which is divisible by 4 is leap year. Okay, like 2020 is leap year. Okay, meaning to say after every 4 year the February become 29. Okay, so in this way you see, and actually the same thing you have studied in C++ language before. Okay, let me show you a quick example. You see here, I think I have one example already for you. Yeah, all of you hopefully you still remember somehow C++, right? So if I define a function like this, that you see int, it will return the return type of this function, and you see the same mathematical concept. This, you see, the same mathematical concept is 100% working in computer. Okay, so you see the computer is also based actually on mathematics. So int, it returns an integer answer. Like for example, in this case, the February 28. So the 28 is integer. It returned to me 28, which is integer. So days of months, it will get an input as a string value. Okay, and then we can check that if this name of the month, okay, is January, then return 31, and if it is February, then 28. Else if until December. So if I run this coding, you see, if I run this coding, you will see the 31. Is it okay? Is it okay? Yes, no? So I just want to show you that you see the function concept is working in computer also. Okay, it will be like this, right? You see f of January, if we replace the m by January by the month, that is input, the output is 31. Okay, what about this? Use a function notation to express the weight of a pig in pounds as a function of its age in days. Do you think is it correct? You can represent as a function? Yes, no, yes, no. Faster. Oh my gosh. Why? You are not sure. You see, please you try to learn the things in such a way that you are 100% sure what are you saying. You see, go back to the definition, and in the definition we said that the input should not be repeated, and if it is, even if let's suppose repeat, you see, so here the 5 are repeated, right? So one time, if it is 5, it will produce 40, and another time if it is 5, it will produce 42. Yeah, 5 is repeated. Yes, good. Okay, what about this? Let's suppose this is one function, this is another, this is another, this is another. Which one is a function, which one not? Tell me, one. Is this function? The first one?
Function.
Okay,
Yes, function.
this. Second, this?
Function.
Okay, this?
Yes.
No.
Yeah, no.
No.
No, very good. Why? Because?
5 is repeated.
Very good. This one?
Yes.
Yes.
Oh, good, great. I think you learned. So it means you proved my theory that mathematics is not difficult.